Hi guys, today we'll be finding the pitch period of a PPG signal and a speech signal using the autocorrelation function. Okay, the period of a signal is very difficult to find out in a normal way, so we take the help of autocorrelation function. So what is autocorrelation function? Autocorrelation is nothing but a comparison between a signal and its time delayed version. We consider a signal x of n and its time delayed version x of n plus m. We compare these two signals and that relates to autocorrelation. Here is the function of autocorrelation. Rm equals 1 by r of 0 sigma n0 to n minus m minus 1 x of n into x of n plus m. M from 0 to n minus 1. These are some of the properties of autocorrelation. Autocorrelation is an even function. R of m equals r of minus m. And r of 0 gives the energy of the given signal. It is a periodic and a monotonically decreasing function. Here you can see the autocorrelation function of some signal, random signal. It looks in this way. We use a property of autocorrelation today. The period of a signal and the autocorrelation signal are the same. So here is the code for finding out the period of a PPG signal. Let's get on. I have taken a sample of 2000. These are some initializations of the variables we'll be going to use. And in setup I have written serial.begin 9600, and in this loop first I have taken an MA filter. I have applied an MA filter to the given sample. A is the output of the MA filter. As you can see, here's the code for it. Next I have found out the mean of the filtered signal. I have found out the average or the mean of it. Then the mean is subtracted from the signal, the filtered signal, and is stored in another variable b. Here I have broken these 2000 samples into set of 500 samples, and for every 500 samples I have applied this filter and all and found out the period. So next we found out the coefficient of autocorrelation r of 0 in this way. As you can see, the function is this: Rm equals 1 by r0 sigma n0 to this one. So I have found out the r of 0 by using this equation here. When you substitute 0 in this equation, we get summation of x of n into x of n. So I've written the code in this way: r of 0 equals r of 0 plus this one. Next I have used this r of 0 in the main formula of this. I have taken two for loops as we have a summation, and this is the autocorrelation output. Aut of I equals aut of I plus p of j into p of j plus I. This is the function of autocorrelation. Sorry. And here I have divided the r of 0 coefficient which we have found out in the above loop. Next, the process of finding period goes this way. First we find out the zero crossing point of the autocorrelation, which means, suppose taken this function, this is the first zero crossing point. We find out this zero crossing point of the function and we take samples from that function and find out the maximum, first local maximum of this function, which means this. R of 0 is the maximum of the total function, and the next maximum comes this. We need to find out, if we need to find out the period, we want this point. So we are finding out the local maximum after the first zero crossing point. So here we, in this loop we are finding out the zero crossing point, this one, if aut of I is greater than 0 and aut of I plus 1 is less than equal 0 and c equals 0. This is used for breaking the loop. In this way I am finding out the first zero crossing point, and in this if loop I have considered a max variable which automatically changes as it runs the loop and gives the maximum or local maximum after the first zero crossing point. So after we get the first zero crossing point, and the distance will be this, like it will be in samples, the L max. L max is nothing but from 0 to this point over here. This will be L max, so which will be in samples. After that, the beat or the period of the signal goes in this way. It's equal 6000 divided by L max gives the period of the signal. And here are the printing for autocorrelation function and the sample, filtered sample. So let's upload it and check the output. Okay, it's done. So here is the PPG signal, filtered PPG signal, the MI filtered PPG signal, and here's the autocorrelation function of it. You can see it is similar to the one which I showed in the PowerPoint. It is showing for every 500 samples, so there's a break here. You can see the autocorrelation function for this MI filtered sample. So we have found out, for every 500 samples we have found out this point, the local maximum, this one, and we have found out this distance L max, and found out the pitch period of the PPG signal. Let's check out the pitch period of the PPG signal. Sorry. So here are the sets of every 4 samples of 2000, like 500 samples up to 0 to from 0 to 2000 taken in a loop. These are the pitch periods of those samples. You can see it's around 60 to 70 in between. So this is done. Our next job is to take a speed signal and repeat the same process which we have done for the PPG signal over here. We need to change the frequency to 8000 Hertz. There's a small change in the code, that's it, and the rest of it will remain the same. We need to change the input of the code here, which I have already recorded the speed signal and changed the sample. So here's the code for the speed signal. These are the sample values of my recorded speed signal, 4000 samples, and the rest of the code remains the same. The initialization of variables, MF filter here, finding the mean over here, subtracting it from the filtered output, finding R of 0 of autocorrelation in this loop, substituting this R of 0 in the main function of autocorrelation and finding the function, 0 crossing and second maximum of autocorrelation function. This loop does that function. It is the same code as for the PPG signal. Here let's upload this code and check out. Sorry. See here, I've changed the frequency to 8000. See, you can notice the change. For the speed signal which I have recorded, the pitch period is 150, around one from 145 to 150. These are also the same from the 4 divisions of 500 samples taken from 0 to 2000, 4 sets